Now it's recording. All right, ladies and gentlemen, we are going to be starting Chapter 16, and we're going to have a discussion on lines in 2 dimensions and 3 dimensions. I'm going to focus today on 2-dimensional lines, and we're going to be discussing them in terms of vectors. So in this picture, you can see there's the origin right there. That's my starting point. And then over here, I've got the actual line that I'm talking about. So the 2 parts that you need to concern yourself with when you're talking about a line in 2 dimensions is the vector that will get you from the origin to the line, and then the vector that will get you from any point on the line to any other point on the line. So the vector that gets you to the line, we're going to call that A, and then the vector that gets you from any point on the line to any other point on the line is vector B. And you might think of vector B as being directly related with slope, because we've talked about slope being the number that allows you to get from one point on a line to another point on the line. So that second vector is very closely related to slope. So what we say is this line R, or this vector line R, is the set of all vectors so that I travel along vector A, and then from there I travel any multiple, which I'll call T, any multiple of vector B, whether it's a big multiple of B, meaning I'm going very far down the line, or it's a very small multiple of vector B, meaning I'm not going very far, or T could also be negative, so that I can go in the other direction on this line and get to some other point on the line. All right, so let's do a couple of examples. In this first example, I'm asked to do 3 things. I need to find the vector, the parametric, and the Cartesian equation of the line passing through the point 1, 5 with direction 3, 2. So it's kind of already set up in vector form for you. The 1, 5 is going to be the point on the line, so you're going to use that as the vector that's going to get you from the origin to some part of the line. So that's going to be like my A vector that I was talking about before. And then direction 3, 2 is going to be how I get from any point on the line to any other point on the line. And of course I can use any multiple of 3, 2. I can use 6, 4. I can use 1.5 and 1. I can even use negative 3 and negative 2. Any multiple of this vector is going to get me to any other point on the line. All right, so if I'm looking at it that way, this is just what I've said. Vector A is what's going to get me to the line. That's my 1, 5 from those coordinates right there. And vector B is going to be 3, 2. They already gave that to me. So I can write my equation of the line as R equals vector A plus some constant T times vector B. So my xy will equal 1, 5 plus some multiple of vector 3, 2, where T is a real number. All right, and then we're talking about the parametric. So if I read across the first row of this equation, then I've got x equals 1 plus T times 3. And if I write that out, x is 1 plus some multiple of 3. And then y will equal 5 plus T times 2. So y will equal 5 plus some multiple of 2. Okay, that's basically, these 2 equations is a splitting up of what I've just written up here. It's just splitting it up into 2 parts. So it means exactly the same thing, it's just written in a different form. Now if I want the Cartesian equation, which is what you've used in Algebra 1 and Algebra 2, then what you do is you can set T equal to 2 things. You take this equation for x and you would solve it for T, meaning you would subtract 1 and you would divide by 3. So that's what T is equal to in this equation. And if I'm solving for T in the second equation, I'm going to subtract 5 and divide by 2, so that T is equal to y minus 5 over 2. And since T is equal to the same thing in both equations, then x minus 1 over 3 is the same thing as y minus 5 over 2. And I can cross multiply those. 2x minus 2 is equal to 3y minus 15. And if I solve it even further, 2x minus 3y is equal to negative 13. So that would be the Cartesian equation of that line in what we normally call standard form. So 3 ways of writing the equation of a line now that we know how to deal with vectors. The vector form of a line, the parametric form, and the Cartesian form, and you need to be ready to do all 3. In the second example, we have a particle, and x and y are both dependent on time. They give me a function to help me calculate the x's. They give me a function to help me find the y's. And so I also need to know that the distance is in meters and time is measured in seconds. So I need to find the initial position of P. Well, initial to you and me means that time is at 0. So that's when time starts. So I'm looking at when t is equal to 0. If I plug that into x, x is 2 minus whatever 3 times 0 is. That's 2. And over here, y will equal whatever 2 times 0 is plus 4. So that will be 4. Okay? So the initial position will be when x is 2 and y is 4. So the initial position has x coordinate 2 and y coordinate 4. And then it moves from there. Okay? Now we need to illustrate the motion showing points where t is 1, 2, and 3. So I'm just going to plug those numbers in and get several x's and y's. So when I plug in 1, x becomes negative 1 and y becomes 6. When I plug in a time of 2, x becomes negative 4 and y becomes 8. When I plug in 3, x becomes negative 7 and y becomes 10. Okay? And if I plot those x's and y's on a line, I can kind of see where the line is going to go. This makes more sense. All right? And so I can join those points and make the line that I'm talking about. And from then I can see what the slope is and find out all sorts of other things. All right? Now, I'm supposed to find the speed of P. Well, the speed of P would be how far it travels every second. And if you look at this line here, each of these little blue dots is separated by 1 second. This is where the point is at the start. This is where the point is after 1 second, 2 seconds, and 3 seconds. So you can see that all of these distances are the same. It's traveling at a constant speed, so I just need to pick any one of these intervals where it's 1 second apart and figure out the distance from here to here. Well, that's distance formula. So what they've decided to do is I guess just kind of copy it over here. And so from here to here, the x distance is 3, the y distance is 2. It doesn't matter whether I'm going left or right or up or down since it's distance. So my x squared would be 9, my y squared would be 2, and if I add those together I get 13. So the distance between these points is root 13. And since that happens every second, I can say that the speed is root 13 meters per second. All right, so if you have any questions or concerns about anything that we've talked about here, please feel free to email me or Facebook me with questions, and we'll talk about it more tomorrow, and of course I'll give you some more practice to do.